beat this delta strain, just as we did a few weeks ago. That the Chief Health Officer and the Public Health team recommended to me and my cabinet colleagues that we lock Victoria down from 11:59 p.m. tonight until 11:59 p.m. next Tuesday night.
What the hell am I going to do for 5 days? Yes, the car is finally painted. Massive thanks to the guys at Eltham Collision Centre. The initial plans for getting the car finished off sort of fell through, and they stepped in and did a really nice job, and a very quick job as well. They even sent me progress pics along the way, which I'm pretty sure is against the panel beater and spray painter's code of conduct. Main shell's done, black interior, the front and rear covers are all done, and I've made up some stands so we can tuck them away while we get to work building the rest of the car. So the colour, probably going to annoy a few people, but it's it's red, and it's an alpha red. It's 501 Rosso red, which is exactly the same colour as my other rally car. I really like the colour. It means I don't have to repaint the workshop. I guess we should start putting it together. Now, where do I start? This bit. I know. First job of the assembly, and I've already got the welder out. But this was always the plan, to get the rubber joiners to the water pipes as far away from the exhaust as I could. These pipes require welding in situ. This is going to be fun. That was a bit of a stressful welding experience, but it's all good. I gave them a quick pressure test and they are good to go. So I've clamped them in place, and we can move on to, I think, the fuel tanks. Start with the passenger side. I've already got the fuel lines to the passenger side run. So we've just got an inlet and outlet and a breather. And this breather tube runs up as high as I could get it up inside this sill, and then does a U-bolt and then comes back down behind the tank and drains out the bottom. I'll go and grab the tank. Move on to the driver's side, a bit more going on over here. Start off with the fuel filter. That's all gone in there pretty nicely. I think we've got a complete fuel system awaiting the engine. Fuel filter is the outlet of the fuel to the fuel rail, and then return here to the fuel pressure reg. Got a fuel pressure sensor, and that goes to this little divert valve, and that can divert the fuel back to either tank. So the next...
So the air comes out here.
Well, hopefully it doesn't. So the next job is to install the oil cooler, and that's Dylan's job. But he said he wouldn't do it unless I'd pressure tested it, which I totally forgot to do. So let's do that now. I really hope it doesn't have any holes in it, because I've already painted it. Put it in, and we'll just put a little bit of air in. Uh-oh. Damn it! There's a hole. There's a hole there. Uh-oh. Looks like the only one.
What looks like the only one? We can fix one hole.
So now we move on to everyone's favourite part of rebuilding a car, the wiring harness. So the first thing I like to do with an older wiring harness like this is clearly we're going to be making a brand new wiring harness for this vehicle. To start with, welcome to the fuse and relay area and whatever we're calling this thing. This was an idea I had to simplify the wiring harness that escalated substantially. Got this nice printed circuit board made up. There's an Arduino based microcontroller sitting at the bottom of it. I'm going to use that to control the pop-up headlight motors and also the windscreen wiper motor and the park function for that. So we've got a couple of chips here that allow the microcontroller to switch relays on and off. Also got the option to control the water pumps, the fuel pumps and the fans, but I'm going to leave that up to the Heltec ECU at the moment. The rest of it's just sort of power conditioning. Got a lot of fuses here so that every circuit's separated. If we get a problem in one area, it doesn't drag anything else critical down. 12 volt, a 9 volt and a 5 volt reg. 9 volt reg powers the micro and also the intercom. Got a couple of reed relays here to switch some GoPros on and off. A couple of high current switch mode power supplies under there to feed the GoPros and also my little dash display. That's another one of these plugs. And this little monstrosity here is a CAN gateway that I've made up. It's actually got another microcontroller under there. The Heltec spews out the CAN messages at quite a high frequency, and I'm concerned that my little dash doesn't have the processing power to keep up. And if it was to keep up with the CAN network, then I don't think it'd have any processing power left over to actually display anything. So this little module takes the high speed or high frequency CAN from the Heltec, grabs the signals that I'm interested in, and then sends them back out at a lower frequency. That's what that is, and that's just a little programming board that sits on top. Anyway, I'm sure we'll go through the functions of that more as we start plugging things into this unit. The rest of it's a pretty standard fuse and relay arrangement. Our two fuse blocks here with a common 12 volts. We'll bring a big power cable into that, and then that just goes off and feeds each individual relay. Time to put it in the car and start connecting the dots. And just because it'll probably look like I'm going completely freeform with the wiring, I am actually trying to follow this wiring diagram that I have constructed. So I did lie a little bit. I have actually already started the wiring harness. I wanted to wire in all the things in this sort of area because once the engine's in, I'll lose a lot of access. So I've already got all the wires put in for the rear lights. The fuel pressure sender is wired in. So is the fuel divert valve for the return of the fuel. And this tank is all done as well. So the fuel pump is wired in and the fuel sender gauge is also in there. Down here we've got the two cables for the wideband O2 sensors, and I'll also be pulling the 6 thermocouple wires through that grommet as well. Haven't got the thermocouple wire that I need. It's on order. Hopefully that gets here very soon. Apart from that, we are ready to insert an engine. So this is the beginning of the wiring harness from that back area that I was talking about. I definitely won't be going through every step of installing this wiring harness, but I'll try and bring you some of the highlights. Where I can, I'm using TXL wire, which is a sort of reasonably high quality automotive style wire. So it's got a relatively thin insulator, and it's got a high temperature rating, or at least a higher temperature rating than sort of PVC, your standard wiring. I think Tefcel, which is a name brand, is even better again, sometimes referred to as mil-spec wire, but it's insanely expensive, and this TXL wire is sort of a step below it, but still has a lot of the same qualities as the Tefcel wire, so I'm going with that. Anyway, I think it's time to start routing this part of the harness to our fuse and relay box, and like I said, start connecting some of these dots. I've changed my mind. This will probably happen a lot, but we're going to run the main power cable first. This is a big solenoid switch that I'm going to be using as the kill switch. This is an industry standard solenoid switch, but it is rebranded by motorsport companies for motorsport applications. It's just a lot cheaper to buy it like this instead of with an expensive motorsport sticker on it. I used one of these in the Alpha for years, works really well, 250 amps continuous and up to 500 amps for a brief period of time, so perfect for a starter motor. This is just another relay and a sort of high power resistor. This relay will pull to ground when the power is switched off and pull this resistor to ground. So that should just help dissipate any energy left over from the alternator as it mechanically spins down. So it just gives it a path to earth so that it doesn't try to find one through like my expensive ECU, for example. So I'll bolt these in and start running some really large cables to it. And there we go, the main switch solenoid is all wired in. While I was at it, I've also wired in the battery. And while I was up the front, I also wired in the thermofans, the water pump, and the little water temp sensor on the radiator. Actually, I've wired in the whole car. Yep, everything except for the engine harness has been completed. I was going to make a whole thing about the wiring, but it was just one of those jobs that I just had to put my head down, not worry about the camera, and get it done. And done it is. There is one last wiring job to do, and this could be a bit of a big one, and that is the wiring in of the switch panel. So let's get started on that. That wasn't too bad. So the switch panel, this is really what initiated that monstrosity of a controller that lives with the fuses and relays. I knew I was going to have a fairly complex switch panel layout. And switch panels, obviously there are a lot of connections, especially when you start having proper feedback lights, or in this case LEDs. A lot of wires, and that starts to get very bulky, and this has to live in a position where there's not a lot of space between the two seats. So the idea was to make up a printed circuit board that sort of worked out where all the connections were and then brought them to a central connector, and then I could use a single ribbon cable to go to the controller and then break all the wires out from there to simplify everything. So that's the printed circuit board I got made up, and these little switches, these are great little switches, they're super reliable. You can get them in all sorts of different switches. This is a two-position switch, center off, but they're all the same form factor, which meant they're all the same height, which means I can mount them on the printed circuit board and they'll all line up correctly. Another thing that's always a bit of a problem with switch panels is making them look presentable. You know, you end up printing out stickers with label makers and then putting them on crooked, and it all just looks terrible. I found this company in the States called Front Panel Express. They've got a really trick bit of software, sort of CAD software that allows you to design your own panel, choose all the cutouts, all the diameters, all the holes for all the different switches, do all the text and any engraving, and you can select a variety of materials. This is anodized aluminium, 3mm, with black infill. Fire that file off to them, and in a week, for a fairly princely sum, they send you back a very presentable switch panel. So the idea is that, so if we want to turn the lights on, flick that to on, that grounds itself and then sends that ground signal back to, in this case, the microcontroller, picks that signal up to say I want to turn the lights on. It then sends the signal out to the relays to control the headlight motors, pop up the lights and turn them on, something like this. So that'll have to do for this episode. Sorry it's taken so long to get something out. I did take a lot of footage of putting things on, but it just ended up just footage of me just turning spanners and really wasn't that interesting. So hopefully I've cobbled a few things together that were of some interest to people. Like I said, I was going to go right through the wiring, but it's a massive job and I really just needed to put my head down and get it done. We are really getting there. Tanks are all done, fuel lines are in, brake lines are done, all the wiring for the whole car is done except for the engine stuff. Obviously there isn't an engine there at the moment. That will be there very shortly. Steering's in, still haven't got the dampers yet, they're on their way, so then we can finish off putting the suspension in. All the water pipes are in, everything's been pressure tested, we are well on the way and it is getting very exciting. So hopefully next time we'll be throwing an engine in, doing a little bit more wiring and we'll see how we go. But until then, thanks for watching.